Alright guys, let's go over this warm-up question over here. Question number 1. What does SUD stand for? Well, we're trying to look for, this is a stats class, so we're looking for something that refers to stats. Soap suds, the bubbles you should make when you wash your hands. I hope you do wash your hands, like Mr. Police says, keeping it clean like a washing machine, but no. And that was just a visual image I used in the notes to kind of help you remember. Subjective units of distress scale. I don't know, I just typed in SUDS into the internet and that's what it came up. So it's not this one. It is the middle one here. This is your answer. What does each of those mean? Strength refers to actually correlation, the R value. Unusual is the outliers, and direction is either positive or negative. And then the shape, we've been focusing linear, but we'll eventually get to quadratic and exponential. So if you look at a graph, if I have a bunch of dots here, the strength refers to the R value. How close is it? That's pretty close, so I might say something like R equals 0.80 or 90. Remember, it has to be between -1 and 1. Outliers would have been something like, something that's unusual is maybe a point like way over there, if it was there, okay? But we don't have something like that. And then direction, just like slope back in Algebra 1 or Math 3 or whenever you've taken it, it's positive. Does that make sense? And then this one is a linear. So that's question number 1. Question number 2. True or false? There is a strong positive correlation, so you can draw yourself a picture. If I haven't been stressing that enough, draw a picture. Correlation between shoe size. This is say 0 and 12, because I have a shoe size of 11, 12. And reading ability. Sorry, reading ability. Let's call it like a score, so like, I don't know, 100 to 0. Therefore, it is reasonable to conclude that having big feet causes children to read better. So first, I'm going to draw what a strong positive correlation would look like, right? This is positive. It's close to that line. So this is basically saying as shoe sizes increase, reading ability increases. That's what it's saying. Well, there's a key word here, and the key word is causes. Can the shoe size cause children's abilities to read better? And the answer is false. Not true. It is false. Why? Because here's the key line. I don't know if you've picked up. This was actually from quiz number 4 as well. Correlation does not imply causation. Just because you have a big shoe size does not cause you to have a greater reading ability. I don't know. I'm just guessing. Like Albert Einstein or Mozart, people who had high IQs, ones if they had a small shoe size. Doesn't that go against this idea that maybe their reading ability was high? They were highly intelligent, high IQs, but maybe they're small shoe size, right? Or people in the past, like they had less food, so like they were smaller. Does that mean like people nowadays who have bigger feet, like they have a higher reading ability? No, that correlation does not imply causation. Okay. I missed a question. Question number 6. A 5th grade class conducted a 5-minute experiment that involved heating time and water temperature. The results of the experiment are represented in this line graph below. In class, we also call this a time plot. And the reason why we call it a time plot is one of these is time, and then over here you're measuring something else that's quantitative or numerical. Okay? So this is perfect because, I don't know if you guys know, most places that you live have something called a water heater, and I'm actually getting mine replaced soon. And in this water heater, they have fire that heats up the water. Right? So if you empty this, if you empty all of it, then it has to be filled back up with water, and then the fire goes on and it heats it up. Okay? So what happens if you heat this for a short period of time? Like 0 minutes. Well, the water coming into your house might be a low temperature, right? But what happens as you increase in, let's make this more obvious. What happens if you increase in heating time? 0, 1, 2, 3, 4, 5. What's happening to the temperature in the water? It's also increasing. Okay, and what I've shown you guys in the lessons, I like doing this because it's hard to kind of show you guys as heating temperature is increasing, as I go to the right, what's happening to the graph? That means the water temperature is also increasing. That's why I have those double arrows there. Okay, what prediction can be made based on the information gathered? The water temperature remains the same as the heating time. So this graph, this is wrong. If it was this graph, you'd probably have like this, a constant graph, okay? B, the water temperature decreases as the time continues. So they're saying that your graph's going to look negative. So in math, we call this one a constant. This one would be a negative. And do you see a negative up there? No. Do green. Now let's try purple. A pattern cannot be determined between these measurements. Remember, if it was this would be a no correlation, and your graph would have dots scattered throughout. You couldn't draw a line. Call it a linear regression line. So it's not this one. And then the water temperature increases. Okay, so we've said that, right? So as you're going this way, as the temperature is increasing, the heat also increases. So your graph looks like that, which is ours. So D is the correct answer. And then the last one, which data will most likely show a negative correlation when graphed? So again, from left to right, the graph is going down. This is a negative. That's what we're looking for. So each of these, then just draw yourself a picture. So let's draw yourself a picture for A. As the outside temperature, so temperature, really cold last night, right? 100 to 0, and that's Fahrenheit. And the number of people wearing gloves, number of gloves. So, question, do people wear gloves going to the beach? Most people don't. So, if it's cold, like 0 degrees, then I would expect like lots of people wearing gloves. I just read that Germany in their COVID-19 in their schools, they open the windows when it's freezing, so kids are wearing like these huge jackets. Yeah, I'd probably wear one. But as the temperature increases, I'm probably not going to wear my gloves to the beach. Okay, so this one looks like a possibility A. Let's try a different one. The distance. So again, this is where you have to do two things. You have to kind of make sense of the problem and draw yourself a graph. That's why I think it's super helpful. Let's try B. So the distance a student lives from school, distance from school. So again, think of Savannah. And 0 to, 10 miles. And the amount of time it takes to get to school. Let's say it's like 60 measured in minutes. Okay, so if you live across the street from the school, how long will it take you to travel? Okay, who cares about preparation time? It might take you like 1 minute. I remember in junior high, I lived so close to my junior high, I can hear the bell from my house. So that's when I actually left the house, right? And then when I went to high school, we were further away, so it definitely took me more time. So if you're further away, of course, most of the time it's going to take you more time. There's traffic. It just takes more time. But this is a positive correlation, so not this one. Let's try C. The number of visitors. Okay, you know, we're in COVID-19 right now, and Disneyland has not opened up at an amusement park, and the length of lines for the rides. Or you can think of it as time wait. I don't know. I had a Disneyland pass a long time ago, and when there were a lot of people, let's just call this 1 million people in the park, and this is 3 hours, right? You're gonna wait. Like, if there's no one in the park, which I've been to, is awesome. I'll tell you, there's a time where I went on a ride, and you wouldn't have to get off until they tell you to. You can literally sit on there, keep going over and over again. I remember this as a kid. So if there's little visitors, then my wait time is very little. I'm gonna keep going back on that ride. But when there's like a ton of people, a brand new ride, there's 1 million people in the park, you're waiting a long time, okay? So that one, again, is a positive. And let's do this last one, the D. Student's height. Let's call this 6 feet. And then GPA. What's the best GPA you guys want? 6.0s. I guess it technically goes up to 5, but whatever. And just because you're a tall person doesn't necessarily mean you have a high GPA, right? I think this will be all over the place. I think this one would be a no correlation. So I think my answer is A. Okay? Hopefully that was helpful.